the last part, which is part 5, part D if you prefer, says using your powers of reasoning, identify which stage would be significantly improved if the small signal current gain of each transistor increased to 500 from 100. So if we look at the circuit again, we had differential pair, and we had a common emitter without degeneration, and that drove a pair of emitter followers. Well, I think this was plus 15, that was minus 15, and there was a load of 2 kiloohms here. And if we increase the beta to 500, it means that our base currents will go down a bit for a given collector current, or if you prefer, collector current would change very slightly, but it wouldn't change very much. As a consequence of the collector current not changing very much, the GM that we work out, which would be GM for anything is EEIC over KT. If IC isn't moving very much, GM won't change a lot, so it doesn't affect that. But if we remember that RBE is beta upon GM, GM isn't changing much and beta's getting much bigger. That's going to adjust our value of RBE quite a lot. And because GM is almost always less than 1, especially in this sort of circuitry, this is going to be sort of in the order of 0.0 something amps per volt. And if we make this 500 instead of 100, we could find that RBEs are going up by a factor of about 5, because it's 500 from 100 from our earlier arrangement where we said beta was about 100. So will this make very much difference? Well, we had this resistor here at 14 kiloohms, and we had the RBE looking in here, so RBE3 was beta upon GM, so RBE3 in the old system we had with 100 for beta, where GM was 0.038 something, wasn't it, I think? If you've just done the sheets, then you'll have the answer in front of you. Yeah, about 2 kiloohms, that sounds right, 2.6 kiloohms. That's about 2.6 kiloohms. So when we had the total resistance down here is 14k in parallel with the 2.6k. This really dominates, and the 14k doesn't have much say. So the overall resistance is going to be approximately 2.4k or thereabouts. It'll go down because they're in parallel. Whereas with our new arrangement, we'll have 500 over about 0.038, which is, if you don't know where this is coming from, go and watch the last couple of videos and you'll see it. In this videos in this tutorial sheet section. So 500 over 0.038 is 13.15 kiloohms actually, in parallel to 14k. So this has gone up to something in the order of 6.8k, I would imagine, from 2.6k. So that's going to yield a much different answer to the gain of the first stage. So we had, for part II, where we did the very long-winded calculation, we had a bit that was to do with the input, which was about minus 5.04, which was the Yeah, due to this is in the output circuit for that question, and we had another one which was to do with the input part, and that gave us about 0.371. So this was the ratio between VBE1 and VI, and this was the ratio of VBE1 to VO1. And this bit was calculated from an equation that ran along the lines of VO1 over VBE1 equals minus GM1 R1 parallel RBE3, where this here was R1. Now RBE3 has just changed from 2.6 kiloohms to 13 kiloohms, and that's made our parallel combination of these two go up to something in the order of 6.8. Let me work out the actual value. 13.16 times 14 over 13.16 plus 14. 6.78. Blimey, that was a good guess, wasn't it? I think I'll leave it at 6.8. I can't remember what we have for GM1. Let me look at the answers. 0.0023 amps per volt, so we had 0.0023 times, and then R1 in parallel with RB3 is about 6.8 kiloohms, 6.78 I think I said actually, times 10 raised to 3, just come up from there. So what does that leave us with? Leaves us with 0.0023 times 6.78 E3, 15.594, and this is volts per volt, because that's volts and that's volts. So this is, oh, there's a minus sign as well, because there's a minus there. So this is our new value for 5.0, so it's gone up by a factor of about 3 and a bit, and that will make the overall gain of our amplifier go up commensurately, where we'd have 0.371, which was the VBE to, or VI to VBE bit, times 15.594, which gives us overall input stage gain of 5.78. So, what would that be? It would be VO1 over VI now becomes 5.785, and we've still got our T3 gain to worry about. If IC3 there doesn't change very much due to the change in beta, which it won't, then the GM for this transistor, GM3, won't change very much either. So there won't be very much difference. The base current will fall, but there won't be very much difference in its gain. So that's 0.5 there. Is it? 5 point there. That's an 8. There's a decimal point there. So we'll still have about 500 or whatever it was we had for a gain of that. Just have a quick look. 577 apparently. So our new overall gain will be times 577 about, so VO4 over VI heads towards 3,338.16 or thereabouts. So the gain of the amplifier has gone up by 3. And this of course is the open loop gain, and all that open loop gain that we've got, when we put some feedback around here, so we'll put some resistive network between the output and the T2's base to set the closed loop gain as if you would for a regular op-amp circuit, we will find that all this open loop gain goes towards reducing the distortion of the amplifier and increasing its input resistance and decreasing its output resistance and making it less sensitive to changes in component values and all the other good things that feedback does. So that's the key thing that changes when we change the beta.